Hi all, this is Velodreamer, and I have a big update on the stand. So what did I change? Added bearings in the joint for the tension roller. Because it turns out that it has to be super easy to move. Otherwise the chain will fall off. Then, I added sprockets here. Now you can put any ratchet here. Well, I added cheeks so that the chain wouldn't fly off. That is, the improvements concern this. The calibration was carried out very seriously. I placed a mark on the chain and counted 100 revolutions of the chain. For 100 revolutions of the chain. Oh, no, for 106.1 revolutions of the chain we must travel 100 meters. Well, now I have ensured that the speedometer shows the exact value. The biggest improvement is the addition of this sensor. I'm checking out the new device. I received such a fashionable device. With separate display and calibration, with all the giblets. And with instructions on 8 pages. As close as possible to laboratory ones from my devices. But here, unfortunately, the scale is only in kilonewtons, grams or kilograms. I don't know what T is. But I check what it shows. This one shows in newtons. We start to pull. Here I am pulling. Well, okay. Where it shows 7, it's actually 70. That is, it now takes into account the tension of this chain. I'll turn it on now. It loads pretty cool. Like this. Or is it auto calibration? But it's more like loading than calibration. Here. And now it shows minus 49 newtons. I'm ignoring the period because it's kilonewtons. The negative value is if you stretch it, and the positive thing is if you squeeze it. We will take this value into account as a zero value, and subtract 49 from the resulting value. For example, I squeeze the chain, and the value changes. And it approximately returns to the same position. We need time and distance. Also, this speedometer multiplies the value in meters by 10, so when it shows 1 kilometer, it is actually 100 meters. Knowing the force on the chain and the speed of the chain, you can find out what power was on it. This meter will measure the power consumed by the engine. Now it shows battery voltage and zero current because everything is turned off now. This one right now has no power. Power appears when the system starts working, and this motor, which operates in generator mode, begins to supply power through this wattmeter to this load. The load is a nickel chromium wire wound on a slotted asbestos board. Now the load is at maximum. Here you can change gear, then the rotation speed will change. The problem with this device is that when the generator is not rotating, there is no power to it and we cannot see its readings, although it remembers them and cannot be seen. We need to come up with an alternative power supply system. Do not know how. Through a diode, perhaps. I select the load and turn on the device. I turn on the test stand. It starts to rotate and pull. And I wait until we've used 10 watt-hours. As soon as a 10 appears here, I stop the test and write down the readings. The chain tension reading will need to be recorded as an average. Turn on the controller. The load immediately went to 0.05 ampere, that is, it sees it. Turn on maximum speed. Minus 47 newtons. We don't take this into account. We need to write down now that 47 is not taken into account. When the tension is at its maximum, you will need to record the readings. Because, again, as soon as I turn off the test, these readings will be reset and I will no longer know what the value was. So, let's launch. We're going full throttle. I don't know what it was. Well, okay. So, I restart the test. I reduced the load. Because at this load, due to the large load on the chain, there is a large load on this thing, it keeps shifting, the chain sags. And the tensioner cannot compensate for the sagging. Because it doesn't have enough leverage. It goes here and cannot compensate. Well, never mind, let's conduct a test at this load, less. And so, after the restart, we got 62. Again, what else is the difficulty? This spring is too strong. It puts too much pressure on the chain. Now, if I click here, the value immediately decreases. I release it and it returns to approximately the same value. The slight inaccuracy is precisely due to this spring. Well, maybe I can tilt this pipe a little here to put this main pipe with the generator vertically and compensate for gravity, and thus achieve values closer to zero at the beginning. In the meantime, here's 64, or 62. Well, let's write 2. Let's run the test again. It seems to be holding steady now. Fixed. What we see on the meters. The current power on the motor is 290 watts, but we get only 94 watts from the generator. So we lost 2/3 of the energy, even more. The dynamometer reading is 202 Newton. Now we see the speedometer readings. And for some reason it seems to me that 10 watt-hours would be too short a test. I probably need to wait longer, at least up to 20 watt-hours. Well, here's what we see. 250 watts enter the motor, but only 93 watts come out of the generator. We can show this to everyone who suggests pedaling the generator and then feeding the motor with this energy in order to get rid of the chain. You will lose 2/3 of your power. There are already 10, so far so good. As the battery voltage decreases, the power transferred to the drive chain decreases, and we see this as a loosening of tension on the chain and a decrease in speed. At the beginning there were 202 newtons, and now there are 198, already 19 watt-hours. We record the dynamometer readings 197 newtons. That's it, turn it off. I didn't have time to see what was here. You feel better, you see in the video. Here you can evaluate the effectiveness. 20 ampere-hours came in, but I don't know how much came out. So, the distance is 2.4 kilometers, in fact it is 240 meters. I need to find something to write on. I found it. (202 plus 197) divide by 2. And this will be the average force on the chain. Distance is s, right? Seems yes. The path is 2.4 kilometers, In fact, it is 240 meters. Time, 4 minutes and 54 seconds. This needs to be converted to seconds. And 20 watt-hours were spent. Energy is E. We calculate what the average power of the engine was. That is, we are looking for peat electrical and peat mechanical. Let's find out the difference between them and find out the efficiency of the motor. 202 plus 197 and divided by 2 we get 199.5 minus 64. Oh, it now shows 61. Okay, let's write 64, as it was at the beginning. We get 135.5 Newton. This is the average force on the chain. Now time, 4 minutes multiplied by 60 seconds. We get 240 plus 54 seconds. We get 294 seconds. This is the force that was applied. Average speed. Divide 240 by 294. We get 0.816 meters per second. One more value we need. We can calculate the real power. 135.5 multiplied by the speed in meters per second. By 0.816. We get 110.6 watts. This looks implausible. Then the output wattmeter read 94. Something is wrong here. Let's continue. Average electrical power. 3,500. This is the number of seconds in an hour. Divide by our number of seconds. This is 294, and multiply by 20 watt-hours. Do we get 244? Well, this is very similar to what the wattmeter showed when working. But the difference between them is too big. I'm not sure about this value. But how can I check? I measure the tension on the chain. There was tension on the chain even before the movement began. I subtracted it. Here it is now. But now power is not being produced. Yeah, maybe you don't need to subtract this value. There is tension, but there is no speed. Okay, let's recalculate. If we do not subtract 64, this is the value that exists when the chain is stationary. There is tension, but no power is produced because there is no movement. Then we consider that here it is simply 199.5. Then the average power will be 199.5. Multiplied by 0.816 meters per second. We get 162.8 watts. This looks much more believable. Now we divide 162.8 by 244 and get approximately 0.67. Multiply by 100 and we have 67%. Motor efficiency is 67%. Well, it was stated that it should be more than 80%. If anyone knows where I went wrong, because I really need help here, apparently. Or is the efficiency that bad? Why could this be so bad? Let's say we remove the load now. The dynamometer reads 10 because the generator is on this side and it's pulling to the right. If I start pushing it to the left, I can get a reading around 0. Let's turn on the motor. The motor is now completely unloaded. And what do we see? That it, just spinning, consumes about 73 watts, no load at all. Well, let's just say it sucks. Then this seems true. What conclusion can be drawn? Apparently, this spring really introduces significant distortions. How much is there? Damn it, I can't see anything. 2 kilograms, of course. I pulled this a lot, although maybe even about a kilogram. That is, it's about 10 newtons. We need to loosen this thing up. It shouldn't put so much tension on the chain. But if we take this into account, then the values are generally implausible. It is obvious that during operation this thing becomes closer to this one, the chain sags, the tensioner compensates for the slack. The load on the chain created by this spring decreases during actual operation, but does not disappear completely. We need to come up with some kind of tension system that would introduce minimal distortion into the dynamometer readings. But it's also a speedometer, it's not just a tensioner. Well, the efficiency of the motor itself may be poor due to the fact that I did not install the original controller. And somehow it seems to me that with the original one it doesn't consume as much when idling. Perhaps this is the problem. If anyone has any ideas, I would be grateful for comments and tips. I don't think I made a mistake in the calculations, but perhaps I received incorrect input data somewhere. Although, if anyone can, check this too, maybe I made a mistake in the calculations. I made a small improvement and it looks like the problems were mostly solved. I changed the angle. The generator is now balanced at the center of gravity. I replaced the spring with a thin one. And now in the free state the device shows 3 Newton. And if I start at the same average load power, turning on, And here we see the same 200 newtons looks a lot like the same thing. In short, now it seems to be working more stable. I'll try to switch it up. Oh, damn, it's hot. I'll try to increase the load. It's unlikely, of course, that it will work. But I don't know how to do this so that I can increase the load. But you can carry out tests this way, but, of course, I would like to load it more heavily. I don't think everything will work out right now, but... Oh, it holds up. Load 280. According to our measurements. Motor load 370 watt. Generator output 130 watts. The results of this test will be in the next video. And they return to value 3 again, very good. Well, with that I say goodbye and see you again.